Check out the simplest way to solve these indicial equations. We have 4 into all of this plus 1 is equal to 2 raised to the power of x. It's very simple. First of all, you have to open the bracket. So when we do that, we have 4 into 4 times this will be 4 raised to the power of x. Then we have our minus here. 4 times this will be 4 into 2 raised to the power of x plus 1 is equal to 2 raised to the power of x. So from here, since we have 2 raised to the power of x here and then 2 raised to the power of x here, we'll try to also express this 4 here as factors of 2. That means we have 4 into 2 raised to the power of 2. You know 2 raised to the power of 2 is 4, right? Then raised to the power of x minus 4 into 2 raised to the power of x plus 1 is equal to 2 raised to the power of x. This is what we have. Then, according to there's this law of indices. If we have something like a raised to the power of n all multiplied by n, it is the same thing as a raised to the power of n all multiplied by n. They are talking about the same thing. So we can actually do that. Why are we doing it? We want this x to go inside and then this 2 to come out so that we'll be having 2 raised to the power of x here, 2 raised to the power of x here, 2 raised to the power of x here. So when we do that, we have 4 into 2 raised to the power of x, 4 raised to the power of 2 minus 4 into 2 raised to the power of x plus 1 is equal to 2 raised to the power of x. So since we have 2 raised to the power of x here, 2 raised to the power of x here, 2 raised to the power of x here, we can decide to represent it with a single letter. Let's say let n to be equal to 2 raised to the power of x. So anywhere we see 2 raised to the power of x, we replace it with an n. That means we have 4, then we have n here. This becomes n squared minus this place will be 4n plus 1 is equals to n. So let us bring everything on one side. So if we do that, if we try to bring everything on one side, that means we have 4 raised to the power of n squared minus 4 raised to the power of n minus n. This n, you take it to that side, then plus this one that is here. So there is nothing this on this side again, so it's equal to 0. But we know that this equation here now is, we can just decide to group this equation from here. So if you group the equation, that means we have 4 raised to the power of n squared minus 4 raised to the power of n, 4n rather, then we can put a minus outside. We have n minus 1 equal to 0. It's going to be a minus here because by the time you say 1 minus times minus is going to give you back a plus. That is why we are not going to put a plus here. So from here, what is common amount within this bracket here? We know we have 4 here, we have 4, we have n squared, we have n. So we can bring out 1n here and the 4. That means we have 4n outside, remaining an n here minus, there's nothing remaining here, just 1. So that by the time say 4n times this, we will take you back to this place. Then here, what is common? Minus 1 is common. Then you have n minus 1. Such that when they say minus 1 times n, it will give you this. Minus 1 times minus 1 will give you plus 1. All of this is equal to 0. So let's collect everything on the outside bracket. So that means we have 4n minus 1, which is this and this. And then this one and this one are the same. So we just pick one of them, which is equal to 0. So when you have something like this in mathematics, it means this one is equal to 0 and this one is also equal to 0. Or this one is equal to 0 and this one is not equal to 0. For this purpose, we are going to check them that all of them are equal to 0. So when we do that, we have 4n minus 1 equal to 0. And that means you can take minus 1 to the other side. That means you have 4n to be equal to 1. Divide both sides by 4. When you do that, your n will become 1 over 4. So let's consider the other case here when n minus 1 equal to 0. If we bring this one to the other side, it means n is equal to 1. So our n is equal to 1 over 4 or n is equal to 1. But remember, we're not looking for n because we're looking for x. It's just that we replace n. We used n to replace this. So we're going to bring it back. So we're going to consider when n is equal to 1 over 4 and then when n is equal to 1. Let's start from this. That is at n is equals to 1 over 4, it means this our n is equals to 2 raised to the power of x will now be n equals to 2 raised to the power of x. Replace this n with 1 over 4. That means you have 1 over 4 to be equal to 2 raised to the power of x. 1 over 4, you know that 1 over 4 is the same thing as what? 1 over 2 raised to the power of 2, right? Which is equal to 2 raised to the power of x. And according to indices, if you have something like 1 over a, is the same thing as what? A raised to the power of minus 1. So if I have 1 over the whole of this, is the same thing as what? 2 raised to the power of what? Minus 2. Is that okay? Which is equals to 2 raised to the power of x. So since the bases here are 2, 2, that means they are the same. We can equate their powers. If we equate the powers, it means x is equal to what? Minus 2. So it implies that x is equal to minus 2. That is for the first case. Let's check the second case. That is at n equals 1. Remember, we had the two values of n. So let's consider this one. Here, we are going to replace this equation, which is n is equal to 2 raised to the power of x. We are going to replacing n with what? 1. That means we have 1 to be equal to 2 raised to the power of x. But 1 can also be expressed as factors to 2. That is 2 raised to the power of 0. We know anything raised to the power of 0 is 1. So that is equal to 2 raised to the power of x. Bases are the same, 2, 2. So we equate the powers. That means our x is equal to what? 0. So the values of this equation, the two values that will satisfy that equation are x is equal to minus 2 or x is equal to 0. So if you understand this solution very well, I want you to try this one. I want you to try this one. If you have 2 raised to the power of 2x minus 3 into 2 raised to the power of x plus 2 is equal to 0. Solve this and then drop your answer in the comment section. And don't forget to subscribe to this so that you continue to see more of this, okay? And also comment on the solution. Bye.